Hey everyone, we are back with an especially nerdy Forensic Pixology video. And by we, I mean with me as always is Corey. Say hi, Corey.
Hey, how's it going, guys?
Quite a while back, we made a Forensic Pixology video for the Sega Master System. And there has been fairly recently a great question asked here. There's a really cool difference between the Sega Master System and the 8-bit Nintendo. It's actually quite a bit more powerful in several ways. And one of those important ways is every sprite that it has can display 16 colors instead of just 4.
Right.
On the 8-bit Nintendo, for all the sprites, you can point them to one of 4 different, basically 3 color palettes. On the Mega Drive, on the other hand, there's a 16 color palette for the sprites, and any sprite can use all 16 colors. But technically, to be fair, one of those colors is transparent, so 15 visible colors for the sprites as compared to 3. But the one benefit of that for Nintendo games is you can tell any given sprite which of those 4 different palettes to use, and that's very often used in games to create recolored versions of objects or enemies, or, the player character might change colors when you use a new power, and that's how that's done in an extremely memory efficient way. Because as everyone should remember, in those old systems, cartridge size, basically the amount of memory the cartridge itself could store, was extremely limited, and the amount of what we now call RAM was extremely limited. So it was really important whenever possible to use that kind of hardware trick, like a palette swap or pointing a sprite to a different palette, to get more visual variety in the game.
Yeah, and the key difference there with the NES, having those multiple micro palettes basically was beneficial, is that you could display the same graphics on the same screen, basically, in the same scene with different color palettes, and you wouldn't eat up any extra memory.
Exactly. For example, the reason this whole question came up was this particular viewer had been looking at a fantastic game for the Sega Master System called Wonder Boy 3, and they noticed some of what looked graphically like the same enemies, a particular snakes he mentioned, appear throughout the game in different colors. But with the Master System only having the one set of 16 colors for the sprite to use, you can't just swap which palette it's using to change color. So he wanted to know how they were doing it for the game, or basically what methods, if any, are available. And luckily, there is an amazing community out there of people that still to this day develop games and stuff for the Sega Master System. So I thought, why not post there to the experts that really know the Master System hardware inside and out? And I got some really good responses that we figured we should cover in a video. And as a quick aside, we should not gloss over the fact that among the extremely helpful and knowledgeable people in this Master System development group is none other than, let's see who this is, Bach. You'll see he specifically mentions Wonder Boy 3 and how in their version they did use the yellow versions of snakes where the original version didn't. Let's follow through here and see who this person is. So let's click on the website, which I already did. And it's none other than Aymar. Sorry if I'm ruining your name. And he is the programmer of the incredibly high quality, which I own, by the way, really high quality remake of Wonder Boy 3, the Dragon Trap for modern systems. So if you happen to ever see this video, thanks so much, not only for making such an amazing game, but also for your help and obvious continued love and dedication for this, especially in the United States, very underappreciated system. Basically, I just reposted the original viewer's question, but I also added my thoughts to the different ways that something like a palette swap could be done. The most obvious being, you certainly can just have the artist recolor the character using other colors in that set of 16 colors. So it's just pulling from a different part of memory in the cartridge. The downside is, since you're using that memory, the artist could have totally redrawn the enemy to look completely different for the same usage of memory. But then again, keep in mind, they also had severe time constraints and budgets to make the games in the first place. So there was the cartridge storage constraint, but also a time constraint. So as it happens in the case of Wonder Boy, they did have enough. Hi everyone, this is Future Mike dubbing over this section because it looks like the game actually does only have the red snakes on the cartridge and uses code logic to change the colors just as an artist would in order to get the different colored snakes. And we'll talk more about that process later. Memory on the cartridge. But don't worry, that's not the end of the video. There are other things that they could have done and that I'm sure other games did to deal with this problem of how can we save cartridge space and get more variety of enemies and other objects by switching colors. But it is like that original guy thought. It's not as straightforward as with the Nintendo. So let's start with the simplest things. And let me go into good old ProMotion here. So here you can see this is the snake in question. And here on this level, it is red. And then here it is in another level as blue. Any hardware with any amount of RAM can pull data from, for example, a cartridge and then manipulate the graphics one way or the other to programmatically change which color, kind of like a flood fill in a painting program. So for example, if we wanted to turn the snake red, since they're currently pointing to these indexes, we could just use flood fill, and I'll turn off isolated fill, make sure that's off. And that simply by replacing every blue pixel with the red for the dark and the light, we've now got the red snake. And that's exactly the work that although he didn't have a great tool like Promotion NG, that's the kind of work that the actual artists in the game made so that they could put the 2 different colored versions or 3 different colored versions on the cartridge. But theoretically, you could write a little bit of code that sometimes, like let's say you're at a part of a level where you definitely are only going to be displaying red snakes, then you could have some code that say, okay, load in the graphics of the snake, whatever color it originally is, and then hand replace those colors, and then put them into the usable memory block that the sprites can draw those graphics from. But everything's a check and balance, right? That process might take a little bit of time, so you might not be able to do it on the fly, but you could do it when it's like fading from one part of a level to another. Like there's a
that would get into some pretty sophisticated code that people might not have time for, and like you're saying, it's performance.
But that's why, like I said, that kind of method would be ideal for as a level is loading from the cartridge. You do that before you fade the level in. And there are moments like that in Wonder Boy, so it would have been the kind of perfect crime. But the only consideration is not just how long does that code take to process. The even bigger concern is, does the code to do the color swapping take up more memory than just adding pre-color swapped versions of art onto the cartridge? Because the code would need to be on the cartridge too. So everything is a tug of war. Well, if you're going to be doing a ton of color swapping for a ton of objects, then almost certainly the code required to do that color swapping would be smaller than having all the different color variations pre-made on the cartridge. But that is potentially a way that you could deal with it. And the other benefit, I should say, of that approach is you could potentially have only the one color variant type in the cartridge, but even if you wanted 2 variants on screen, you could theoretically load in the original into a part of the sprite tile bank that you're going to use for one of the snakes on screen, and then do the recolor and put that in a separate piece of the tile set to be used for the other. So you could, you have to do that pre-setup and stuff before the level starts. But then you could have 2 different colors on screen at the same time, just as you could if you already had it using that cartridge space. So that's one possibility. If you don't ever need them both on the same screen at the same time, then you have even more options. And one nice one is something that Corey actually has demonstrated in this ProMotion file here. So if you want to walk me through.
These are just examples that I came up with of something that would be like a top-down sort of game. The idea here is the characters on top would be player characters or, people, so to speak, in this world. The bottom would be enemies. It shows what you could do if you reserved colors in the palette for various reasons. So
Right.
you have at the start there's those 8 values. Those would be universal to all sprites across the board. So any of these characters could appear with any other characters,
Right.
But then say the difference with the enemies and the players is that, well, the players, you would maybe only have one of them always. So
Right.
they wouldn't all necessarily need to be displayed at the same time. So that second set of colors, you could swap the blue for the green or this other.
Yeah, let me show that
yeah,
right now. So
yeah.
you could see going across here is basically what would be the base 16 colors that could be changed or used for the sprites.
Right.
And
exactly.
then that's arranged exactly like how you see here. So Corey organized it nicely. And since he's saying these are swappable with each other, you could see it's only using one color index of the 16 color sprite palette, but he's given me in a nice organized ways the other color variants that I can swap to. So you'll see if I press the S key in promotion for swap and click on the color I want to swap with, you'll see that they now have green skin and that these blue clothes are now green and so on. It still looks great, and we've just changed one color on the fly. So that is one of the other options that was available. Obviously, you don't have to only do this with one color, but look how effective changing that one color index was. So in the case of the snake, you saw it use 2 colors, a dark and a light. You could do this exact thing. If you reserved 2 colors that certain enemies use, you can't have 2 different colored enemies of that type on screen this way. But at any point during the level, if you know, okay, in this section, we only want blue ones, then all you do when you get to a certain part of that level, you just change that color index in the sprite color palette. And now any, in this example, snake that appears on screen is now going to be that color variant. So let me swap that back so you can see.
Yeah, and then the second part up there that says unique, let's say that you needed any character that wouldn't be on screen with another character, but it needed just a unique color for itself. You could set those up per character. That way, the difference there being they wouldn't all share them and all look good with that same color. But
Right.
you've got it there in case, like, say like the red devilish looking guy or whatever at the bottom, he's got his own version of that. And then, but I need that lighter color for the Cyclops that's really unique to the Cyclops. It's pretty simple, but this is just an artistic example of how a lot of SMS games didn't go quite this far with it, but you can take it pretty far if you enable the enemy pal variants. This is an example of, say you design levels where you're definitely going to see all 3 of these enemies on screen at the same time.
Yeah.
You would use this sort of method, right? So it's like, well, they could all look good with the same color swap. And you want your most basic colors to be shared, like, sort of
white
a
and black
grayscale or, maybe some blues or whatever. In the case of this Wonder Boy thing, though, my theory actually is that they originally didn't want to have to replicate the graphics on the cartridge.
Right.
But at some point along the line, maybe a level designer or something needed 2 different colored snakes. At that point, they just made a calculation and they were like, well, we've got extra
Got the room
space. Yep. Yeah, and that's what they decided to do.
If the game's otherwise pretty much done, you have a little room to spare and you'd really like a color variant on there, it's the easiest path to just get what you need to done. No harm, no foul. That space would have gone to waste anyway, because there's specific memory size cartridges that you can produce. It's not like you can make it exactly a certain amount. It's going to be rounded up to whatever increments. So I had the same thought. Like, there was room. It was the easy way to do it, super fast for the artist to do, no programming required. And please do, if you're interested at all in this, viewers, please do consider watching that full-length video, because we go on to pretty in-depth on how powerful the Sega Master System is. But one of the other really cool powers that it has is that there are 2 separate 16-color palettes. Yes, the sprites can only use, I think, the second set, or, we'll just say one of the 16-color sets. However, there's a whole other set. So there's potentially 32 color indexes, or you could say up to 32 colors on screen. And background tiles are able to use either of the 2 16-color palettes. So every tile can use all 16 colors from either palette. And imagine that extra mileage you get when you're creating your level art. Every tile you make can do the palette swap and therefore have a variant look to it if you want to. And you could have like a 31 color background, and then every sprite on there can be 16 colors. So you could really make drastically more colorful looking games than you could on the NES. But anyway, the reason I bring this up, let me see if I can get to that moment in the actual long play. Sometimes enemies, especially that are not moving, don't need to be made out of sprites at all. So here's another fantastic option for saving memory and doing the color swap thing even on the Sega Master System. If you have enemies that animate but don't move around smoothly on screen, or if you're willing to accept that they'll move around screen in 8 pixel increments, you can palette swap. So if you arrange the two 16 color palettes so that no matter which of the two palettes the tiles are using that represent that enemy. So look at this little crab guy down here that spits out this fireball.
Right.
So it scrolls with the screen, of course, but it's a non-moving thing. It's just animating. It's switching which tiles it's displaying. So the great thing about that is not only is it not wasting any precious sprites there. So there it is red, that crab creature, and you'll see later, here it is, the exact same art, but now it's blue. So they very well could have made those as tiles, which would have been the smart thing to do. But anyway, so that's one of the other options. Before we get into the most complicated bit of programming trickery that you could do to get actual color changing on the Master System, let's talk about another way to get visual variety without swapping colors in any 8 or 16-bit system.
On the NES and Sega Master System, you would have sprites made up of 8x8 tiles. Basically, each of these guys is kind of a bunch of those small tiles put together, and that's how they would draw larger sprites. They would just take the same character bodies and swap out heads to make completely different guys. I pointed to these developers. I think these are the same people that made River City Ransom. There's a lot of that going on in that game too, but this game was super dodgeball. They made such drastic changes to the faces and heads that they definitely feel like different people. It works here too because they're in uniforms, so it doesn't seem as out of place or anything.
Exactly.
But that is something that would probably still, I guess, require a little programming trickery.
This body part kind of swapping trick is something that we're actually using in our 16-bit retro beat-em-up game Metro Siege. We have, of course, far more memory to spare, but Metro Siege still can run on not only modern systems, but 35-year-old classic Amiga computers that did have still some pretty drastic memory constraints. And in order to get different looking enemies on screen that could do lots of different animations with lots of different frames, what we did is all the characters are made out of body parts that we move around as much as possible to create new animation frames and swap out a limb, etc. when we really need to completely change the look of that limb to complete an animation for like throwing a punch or whatever. The other nice benefit of that is because the characters are already broken up into body parts, you can just swap out the head or swap out the head and the torso and end up with a very different looking character. So that's like a more advanced version of what they've been doing for ages. But there is also an actual programmatic, very complicated way to actually change colors. That's actually related to another trick we're using in the Scorpion Engine game project we're working on, also that can run on classic Amigas, that uses an obscure trick of manipulating what's called bit planes in order to create those translucent color effects. Something very similar can be used. So you can do that same exact thing. So let's say the artist organized their palette into sets of 4 colors and then made art making sure they're limiting which 4 colors they're using. Let's say the first 4, for example. What they can do is use a coding routine to take that data and shift over which color indexes of the palette are being used to draw those 3 different colors. So you can see here they're explaining it here. A setting of 0 basically would use colors 1, 2, and 3, and then a setting of 4 would use colors 5, 6, and 7, and then a different routine.
Interestingly enough, this is almost like mimicking what the NES does.
Hardware does.
On the fly, yeah.
Exactly. This is saying plenty of time to read, and you could do it at the same time you're horizontally flipping This person seems quite confident, and I think they actually made example code for this. Posted here in this topic. Yeah, loading, flipping, expansion routines. And it looks like it's fast enough to be very usable. So that's pretty darn cool. So basically, in order to get the benefits of the kind of built-in hardware 8-bit Nintendo technique that comes with the limitation of using 3-color sprites, if with some clever coding and also working in 3-color sprites, you can get the same effect on the Master System.
Right.
So that's pretty impressive. But I would venture a guess that this is a very modern trick, and I'd be amazed if any of the old classic games that came out back in the day used this, especially because back then there were much lower standards for how much visual variety a player was expecting in an 8-bit game. We come back with these higher standards and say, how much farther could we have pushed things? How many more colors, how many more moving objects, all that stuff. It's the kind of stuff nerds like us love.
To add to the thought of if you have to pre-process some things before displaying a level or something, if you needed your game to be seamless, I think there are some games that do this kind of stuff back in the day. You can get creative with the idea of buffering your levels with little in-between areas that either have a limited palette or have limited performance going on if you needed to process things before you got to the next screen, and just make sure that your character couldn't reach there until it was definitely finished.
Exactly. Yep. That's a great point. Like, look here is a perfect example. Right now the screen is empty. It might not be so in the real game for the entire duration, but you could see the only enemy on screen is probably not made of sprites at all. So you could manipulate a huge chunk of the sprite palette, like the player is sprites and these red shots are sprites. But that still leaves many, many indexes of the sprite palette that you could manipulate for the entire amount of time it would take for the player to traverse from one side of this stretch of the level to another. And you could get away with programmatic and color swapping murder in that amount of time.
Yeah, same goes for level palette swapping. Like if suddenly you needed all of this greenery in this level to be something different in another part of the level, but you didn't have the palette for it and you needed to swap those, you would just create a portion of the level where it's just the ground without that greenery and enough length there. You can change the palette without that being obvious on screen.
Tile animating is something that the 8-bit Nintendo could hardly do at all on its own without helper chips built into the specific game cartridges like Super Mario 3 and some other later generation games, whereas the Sega Master System was a ridiculous powerhouse when it came to background tile graphics. So you did not need to increase the cost of each game cartridge that wanted to use the feature. And the two extreme examples we covered were Golden Axe and Altered Beast for the Sega Master System that did not use sprites at all for the characters or the enemies. Literally just everything moving on screen were background tiles, which has that one huge drawback, which is that they can only move in 8x8 pixel increments, so you get very choppy movement. But that's a trade-off in order to receive the fact that you can have massive objects on screen with no flickering. That happens very quickly with either of the two 8-bit systems. And the other amazing benefit of using tiles is on the Master System, it could not flip sprites on the fly, whereas the 8-bit Nintendo could, which was one of the few actual benefits the 8-bit Nintendo had. But if you're making objects and stuff on screen with background tiles, now you can flip them for free on the fly as well. And keep in mind, like I said, you can display any background tile graphic with either of the two 16-color palettes. But anyway, I think that does it for this video. Hopefully it was interesting, entertaining, and educational, and thanks very much for watching. We are back with an especially nerdy Forensic Pixology video, and by we, I mean with me as always is Corey. Say hi, Corey.
Hey, how's it going, guys?
That pause was me actually thinking, should I say by we and by especially nerdy? I mean, with me as always is Corey. But anyway.
If you enjoy our content and want to keep up to date on our games, please leave a like and subscribe. Also, if you want to support our projects, consider becoming a patron. The link's in the description, and we'll see you soon.